3. We want to determine the critical value or values for a right-tailed test of a population mean at the alpha is equal to 0.05 level of significance with 20 degrees of freedom. So this refers to the t sub 0.05 with a degree of freedom, so df, of 20. So since this is a right-tailed test, as we were told over here, right-tailed test, the picture that corresponds to this is going to look very similar to the normal curve, but not quite, with a mean of 0. For 5% right-tailed test, that will be over here. We do not know what this value here is, but we want the area to be above it to be equal to 5%. So we have the probability we have a t-value greater than some t-value, I'm just going to call it with a little t, is equal to 0.05. So in Excel, to find that little t, we are going to use the following function. And this takes the form of t dot inv. This uses 1 minus the confidence, the level of significance. So 1 minus alpha, comma, the degree of freedom. So we are using t dot inv of 1 minus 0.05 is going to be 0.95 for the area to the left of this value of t, and the degree of freedom is 20. So if we toss this into Excel as I will model here on the right, this will equal to t dot inv of 0.95 comma 20. And this gives us a t-statistic that rounds to 1.72. Likewise, for a two-tailed test of a population mean at the 1% level of significance with a sample size of 11. First and foremost, since this is a sample size of 11, the degree of freedom, which takes 1 minus that sample size, will be 11 minus 1, or 10. So what this refers to as a drawing, again, mean is 0. We have our t-statistic here on the right, and since the t-distribution is indeed symmetric around the mean 0, that means we also have the negative of our t-statistic here, and we want the area to the left of the negative version and to the right of the positive version. We want both of those to add up to be 1%, which means both of these areas are going to be 0.005, since these are supposed to be symmetric and hence be equal. So for this, we want the probability we have a t-value that's not equal to some little t is equal to 0.01, as we have on here, what these two add up to be. To find the value for t, this one uses a slightly different variation. Since this one wants a two-tailed test, this one's going to use t dot inv dot 2t. That means the inverse of t with a two-tailed test. So this one takes the form of, and where am I going to write that? That way it looks nice and readable. Let me make this not as giant looking. There we go. T.in T.inv of alpha and the degree of freedom. So this will be alpha is 1%, so 0.01, and the degree of freedom we just had was 10. In order for us to get both of these values of t. So tossing this into Excel would give us the following. So this would be equals t.inv.2t of 0.01 comma 10. This would give us a t-statistic here of 3.17. But we're supposed to have two of them because this is a two-tailed test. So since this is symmetric, this would be positive and negative 3.17.